Hello, Precalculus student. This video is for chapter 5.1, part 2, still on angles. So in the last video, we put angles in standard position so that we can define what is a positive angle and negative angles. But we are still restricted by the fact that the angles has a fixed measurement degree. So we want to have another measurement where there is no unit. Just like when we create a function f of x, x could be just any number, and we can just define what our measurement would be. We can say x is time, or we can say x is length in inches or whatever. So the way we do this would be to use arc length. Okay, use arc length. Because if we measure something, we can have it compared to another measure as a unit, and so that number become having no units. So we know that if we have a circle and we want to find, well, the whole circle's circumference is 2 pi r, right? So 2 pi r is circumference. We know that. But if we just measure part of the circle, so if we have an angle in the circle where the center is where the vertex is, and so that we call this the central angles. Then these two radius that is the initial side and terminal side of an angle will cut a arc length, an arc, right? So this arc length is defined as r times theta, an angle. But then this is of course not degree. So, and then we will use this angle as S over R, the size of S over the size of R to be an angle. And so this would have no unit because if R is in inches, S will be in inches. And this is just a ratio, meaning the angles tell us how much, how long this S is compared to R. That means how many radius we are talking about to describe this angle. So if I measure a radius of 1, like the same length of a radius, my angle is called theta equal to 1. We call it 1 radian because it's one. It corresponds to 1 radius length. And so if I go through 360 revolution, then the angle is 360 degree is 2 pi radian. Why? Because that's 2 pi r, 2 pi times of r. So we would use angle as, one revolution is 2 pi radian. Now radian actually has no unit, but we actually just add radian at the end to tell us that, oh, it is as if your angles, your arc length has gone through 2 pi times of the radius length. Okay, and if that is the case, 1 radian is 1 pi. Oh, no, 180 degree is pi radian. 180 degrees pi radian. That means usually we'll measure 180 degree here, right? But how long would it be? How many radians am I doing? So you can imagine if I imagine this is one radius, around here is another radius, right? So this is r equal to this is the theta equal to 1, and theta equal to another 1, so theta equal to 2 is around here. So theta is equal to 3 is about here, and exactly at 180 is 3.14, which is pi. So 180 degree is pi radian. Okay, it's pi radian. It's 3.14, roughly 3.14. So if you go radius, if you have a circle of radius r, you walk 1 time, 2 times, 3 times, 3.14 times, that is about 180 degree. And this measure of an angle is have no unit, and it will be useful for us to make the trig function that is periodical. So now, if we do that, then we would have different name for the angles, right? When we say 180, we would say angle equal to pi. So what about other angles? So I'm going to use another picture or another space to talk about this. So if I have a circle, or if I have to draw a circle. In the old day, we have 0 degree, we have 90 degree, right? Because if it go to here, and we have 180 degree, we have 270 degree. But now, if you use radian to describe it, we know this is equal to pi, right? I'm going to use another color. We say this is pi. This is 0 pi, and this is also 360 is 2 pi, correspond to 360. I'm going to add 360 here. Oh, here is equal to 2 pi. And of course, 0 degree is 0 radian. But what about 90 degree? So 90 degree is between 0 and pi, so we'll call it pi over 2. We usually represent it in improper fraction as pi over 2. We don't say 1 pi, 1 half pi. We don't say 0.5 pi. We just say pi over 2. And what about 270 between pi and 2 pi? That would be 1.5 pi, right? But we don't write that. We don't do mixed number. We say 3 pi over 2. So 3 over 2 is 1.5, but we would do improper fraction and actually say the whole thing at the top, 3 pi over 2. Okay. So the fact that pi 180 is equal to pi is very useful. So for the special angles, and then 90 degree is pi over 2. Help us to know what is 45 degree. 45 degree is half of 90 degrees, so it'll be pi over 4, right? So we can tell that this, use another, this 4, that we have in the middle of these. So this used to be what degree? Would be 45 degree, right? And this used to be 90 plus 45 is 135 degree. And this will be 180 plus 45 degree is 225 degree. And this one is 360 minus 45 is 315 degree. But this, how do I label them in pi, or in terms of radian would be, this is pi over 2 and it's 0. It's between them will be pi over 4, right? So how do I label 135? I will label it as pi minus pi over 4. So you need to get used to how to do fraction. Minus pi over 4. I have 1 pi. I go back pi over 4 because this is pi over 4 and this is also pi over 4. So instead of adding pi over 2 plus pi over 4, I always think of from this line, adding and subtracting. From 2 pi minus pi add or subtract. Okay, so you would say minus an angle. This would be pi plus an angle. And in this quadrant, I think of 2 pi minus an angle. Okay, so pi minus pi over 4 is 4 pi over 4. Use common denominator minus 1 pi over 4. So that would be 3 pi over 4. And this one would be pi plus pi over 4. So again, I use common denominator, 4 pi over 4 plus pi over 4, 5 pi over 4, right? And then this, for this angle, I will think of 2 pi minus pi over 4. So do it here. 2 pi minus pi over 4 would be equal to 8 pi over 4 minus pi over 4. That is 7 pi over 4, right? So I have these angles that I know in radian. Exactly pi over 4, exactly 3 pi over 4, 5 pi over 4, 7 pi over 4. So that's the way how we know angles in the from 0 to 360. But before we go further, I want to also do 30 degree and 60 degree, but in the next video. But let's go back and look at how do I sketch this. Okay. Negative 3 pi over 4. Sketch negative 3 pi over 4. Where is 3 pi over 4? 3 pi over 4 is like it was here, right? But negative means go like this. So negative means just over here, sketch like this. Negative 3 pi over 4. That's my terminal side. Sketch 9 pi over 2. 9 pi over 2 is more than 2 pi, so we'll keep on subtracting 2 pi. Is that okay? No. If I do this, that will just be 5 pi over 2. 5 pi over 2 is still more than 2 pi, so I subtract 2 pi again, just like we subtract 360. That is half pi, right? Pi over 2. And where's pi over 2? Pi over 2 is here, right here. So I'll do it here. So this is 9. Oh, well, actually it is. I have to do one rotation first and then come back. Is it one rotation? No, two rotation. Two rotation and then come back here. So that's 9 pi over 2. Okay. So that is easy if we have if we have over 4 and over 2. We kind of know where things are, right? So a common things that I usually do is if I draw a circle and then locate a common radian is I would put 0 degree and also 0 radian, and this is 90 degree and also pi over 2 radian. 180 degree is pi radian. 270 degree is 3 pi over 2 radian. And I kind of know that this is pi over 4. Why? Because it's 45 degree, right? And then we can tell the other one also. But what about if I have like 10 degree? How do I know in radian what it is? So we have these two formula that we can use. If you want to convert from degree to radian, you multiply by pi over 180 because pi is 180. It's kind of like the unit factor conversion method. If you want to change from radian to degree, you want degree in the top, so you would multiply by 180 divided by pi. For example, 15 degree to radian. 15 degree is, I am going to change it into radian, so I multiply by pi over 180 degree. So you have to say degree. Okay, if you don't see degree, it is a radian. So that would equal to pi over 12. So this is exact value, right? Exactly pi over 12 radian. Don't write any degree. How about negative 126? So negative 26 is a degree. Again, I do negative 126 times pi over 180, and I would have radian. So that would, if you simplify, they're divisible by 9, 20, divisible by 9 would be 14, divisible by 2 is 7 pi over 10 radian. Okay. Convert 3 to degree now. Do you see that 3 is not 3 degree? It's actually just 3 radian to degree. So I would do 3 times 180 over pi. So for exact value is 540 over pi degree. And if you divide it by pi, which is in your calculator, that would be 171.9 degree. Convert negative 3 pi over 4 to degree. So you can do negative 3 pi over 4 times 180 degree, because it's a degree, okay, over pi. So the pi and pi cancel. Basically, you would do 3 times 180 over 4. That is negative 135 degree. So this is exact. But in cases like in this case where this is an exact value, but this is the approximate value. Okay. And again, if you see an angle written as in like 2.5 with no degree, it means it is radian. If someone write 2.5 degree, then it is in degree. So just watch if there's any degree. And I'll talk about how you can locate how you can switch between different degree and radians in a calculator in the next video.